Share my screen. So, first thing, I'm hoping that all of you, when entering the room, you're being muted. So please keep the mics on mute. And please post all of your questions in the chat box, and we will answer them accordingly. Additionally, to get a clear audio, please disable your camera for a clear presentation. So welcome and good evening for everyone who has joined us. This is a session for the LEED 101 for LEED version 4. We're going to talk about green building basics and LEED. First thing, I want to introduce myself and my colleague Deepti. So I'm Mohammed Al-Sarf. I'm the regional manager for GBCI in Saudi Arabia. Joining me is my colleague Deepti, who's the regional director, market transformation and development for GBCI Middle East, and our managing director, Gopal Krishnan Padmanabhan from India, manages all of the Asia Pacific Middle East region. Deepti, if you want to say hi.
Thank you, Mohammed. Hello, everyone. Good evening, and thank you for joining today's session. GBCI Middle East, as my colleague mentioned, we're headquartered in the United Arab Emirates in Dubai, and we cater to all of the other regions, including Saudi, which is a huge market for us. We also support projects in Egypt and through North Africa, and the other GBCI offices manages projects and partnerships in other parts of the world. In the UAE and in the Middle East specifically, we work very closely with clients and consultants. We work with government bodies, private entities to ensure that all of you have a seamless experience with regards to LEED project certifications. Today's and tomorrow's session is our very first set of sessions, and it's also a Ramadan special session hosted by my colleague to bring the latest in LEED to all of you, and also to help you gain your accreditation. So with that, I hope you enjoy the session, and we'll connect soon. Thank you.
Great, thank you, Deepti, for that. Okay, so some disclaimer that the copyright for this presentation is protected by US and international copyright laws. Production distribution for this presentation without written permission of the sponsor is prohibited by USGBC. So in the very beginning, this is kind of like the structure of the sessions that we will be hosting as GBCI, and starting with this session, which is the LEED 101 session. This is a level 100 awareness session. Tomorrow, we're going to have the second level, which is a deep dive understanding into LEED version 4 and preparation for the LEED Green Associate candidate credentialing. Further to that, there's other opportunities that we can organize with a collaboration with our USGBC faculty, whom I'm going to introduce to you later. So basically, this is kind of like a guide and an introduction, a gateway to your credentialing. For the first level, which is the LEED Green Associate. And then after you have passed the LEED Green Associate exam, there's actually a second level, which is the LEED Accurate Professional. And then there's 5 specialties within that specialty, starting with building design and construction, interior design and construction, and then operation and maintenance, homes, and then neighborhood development. Finally, the prestigious LEED Fellow status is the final stage of the credentialing program. But all information regarding these levels are available online. And to give you some good news that the exams can now be taken from home. So the announcement was done on the 12th of May last week that all credentialing exams can now be taken from home. Which was something that was due to the closing of all testing centers in the region and in the world. So you can access the exams online. You can find some information on the USGBC platform and exams given by the prometric.com website. So that's some basic information on what's happening in terms of updates. So let's begin with what is a green building. So all of you here are rather not have some information, some interaction with sustainable and green buildings. So it's quite frequent that when we discuss green buildings, people see this image in their heads. This is what a green building should look like, or characterized as something like this. But in general, what's the expectation, and hopefully the image will change when we go through this presentation, and you'll learn what is the green building basics, what is the role of USGBC and LEED, and especially the LEED system version 4. We're going to look at recognizing the intents of each LEED V4 credit category in general. We're going to explain key sustainability terms and concepts, identify green building best practices. We're going to examine cutting-edge examples, explain cost considerations, and recognize your role in the green building industry. So to begin with, the U.S. Energy Information Administration states that buildings are the single largest contributor to global warming, accounting for almost half of total annual U.S. energy consumption and CO2 emissions. Now, additionally to that, the Environmental Protection Agency has stated something similar to that, but in a global perspective. And generally, what we try to align with are the triple bottom line of sustainability, which are the environmental stewardship, economic prosperity, and social responsibility. So with those three pillars in mind, that's the definition, or the basic definition of what is a green building. So we can summarize it as the triple P's: people, profit, and planet. So in short, we build green to transform the way buildings are designed, built, and operated. And it's very important to recognize why is it important to consider green buildings. Because basically buildings account for 73% of electricity consumption, where 41% of energy use is basically towards buildings. 38% of all carbon dioxide emissions, 17% potable water consumption, 40% raw material use, and 30% of waste outputs. Okay, and when we go through the presentation, you're going to see some elements. I'm going to refer back to these kind of like goals and objectives of green buildings. So basically what we're going to address in terms of green building, and especially in the LEED system, are these facts. First, we start with the climate change, resource depletion, water consumption, degradation of ecosystem and habitat, indoor environmental quality, occupant health, comfort, and productivity, finally, cost of owning and operating a building. So all of these are considered to be the objectives where the LEED system has been built up. And generally, we want to see how can we really achieve these figures. So green buildings can reduce basically energy use by 25%, and in some cases even more. CO2 emissions can be reduced 34%. These are based on some studies. Water use 11%, maintenance costs 19%. And those figures are very, very kind of low when you consider some of the aspects that we can use and apply nowadays. So basically, when we also think of green buildings, the first question that usually comes is the cost. So defining the cost of building. So is it an addition to a standard building, or is it a different type of building? So that's the question you need to ask yourself and see whether or not this applies really to the concepts that you know, or will it change after this presentation? So the business case for green buildings states that green buildings have been shown to save money through the reduced energy and water use and lower long-term operations and maintenance costs. And this is true for certain types of buildings where we see the initial investment is being very moderate or even lower than the normal cost of traditional buildings. And we're going to see some examples on that. So the USGBC's mission is to transform the way buildings and communities are designed, built, and operated enabling an environmentally and socially responsible, healthy, and prosperous environment that improves the quality of life. So it's very important as we go through these slides to remember this mission, and also this will be something that you will be questioned on when you take the exam. So basically, to break it up for you, think of the building in 3 phases during the design, build, operation, and then what is being done on these types of phases is to basically enable an environmentally, socially responsible, healthy, and prosperous environment. So these are the 3 pillars that we talked about sustainability. So this is kind of like the current market in the construction industry, where we have the majority of buildings in the typical building practice sector. And we have some buildings going in the green building market leader sector, and a very, very limited number of buildings in the innovative sector. So what we want to do is to basically, through the USGBC, through LEED, all of these green building rating systems, is to shift the market towards having the majority of construction being in the green building market leaders section, and increasing the innovation later on. And basically, we can do that through the transformation of the conventional building process. So this is an example of what a conventional building practice is. You have different stakeholders here. For example, you have independent design of HVAC insulation and window systems. So each one of these represents one of these systems. So HVAC system is being designed separately, and then you have the insulation guy, and then you have the window system people, all of them thinking on their own, designing for the owner. What is the result that comes out is you're going to have a large HVAC system which has minimal insulation in the building with less effective windows. So in conclusion, what's going to happen is you're going to have a higher first costs and a higher operating cost. So that's what's happening now. That's the conventional building. That's where the peak of the curve is. What we're going to do through green building is to change that to have it as an integrative design process. Okay, so the difference is we still have the same systems. The only difference is all of them are talking to each other. So the integrative process is basically all of these people, all of these systems talking to each other. This means that we're going to have a smaller HVAC system with more effective insulation and high performance windows. So this finally leads to lower first cost and operating cost. So this is in a simple form, the answer to the people who are asking about green buildings and costs. So the thinking needs to shift. Okay, so the thinking of why should I go for green buildings? Why should I opt to go for LEED? It should change based on this simple definition. Is basically you're going to shift the costs from being high, especially in the operation maintenance period, to minimizing it based on the systems and making it optimized. So the integrative approach basically has all of the key stakeholders talking to each other from the very beginning of the design phase as much as possible. So even in the early design, in the early concept phase of the project. So you have, for example, your design team, you have your client team, you have your builder team. So you can see many stakeholders should be on the table talking to each other, where everyone should be applying their ideas and their concepts to achieve the owner program requirements. And what we do through the USGBC is basically we provide tools and expertise to enrich and enhance the market to reach the goals of the mission that's stated before. We build communities to also help these communities dialogue and connect to each other. These connections can be done through forums and industry dialogues such as this forum and many others that we're going to have. And we try to educate the industry and public and USGBC stewards market transformation. So these are considered to be what USGBC commitments are and the structure and process of involvement commitment to the construction industry. So LEED is a brand. The USGBC has its flagship brand as LEED, so it's a leading edge system for certifying the greenest performing buildings in the world. And it's a point-based system. We're going to see some details on it in general today, and then we're going to have some more deep dive in that session tomorrow. But basically, what I want you to focus on are these 7 key goals of the system, starting with reducing contribution to global climate change, then enhance individual human health, followed by protection and restore water resources, protect and enhance biodiversity and ecosystem services, promote sustainable and regenerative material cycles, build a green economy, and enhance community quality of life. So everything that we're going to talk about in LEED will refer back to these system goals. And the types of buildings that are applied under LEED basically are defined by 5 main categories. So we have the building design construction category. And underneath the building design and construction, we have these types of buildings. And then we have the interior design and construction, followed by EBOM, which is the existing building operation and maintenance, homes, residential, and then neighborhood development. So these are the 5 key categories for different systems under LEED. And we're talking here on LEED version 4. So it's very important to focus that the credentialing exams now are only taking the information from the LEED v4 system. Some of you might heard that the LEED version 4.1 is out there for the buildings, but it's not for the exam. So for those of you who are focusing here with us today and tomorrow on information to help you and guide you through the exam, all of the information we're going to talk about is under LEED version 4. That's what the exam is going to cover. So that's for generally the basic definition of different systems under LEED v4. Now, it's very important that the projects apply the minimum program requirements, and there are 3. So it must be in a permanent location and on existing land. It must use reasonable LEED boundaries, and it must comply with the project size requirements. And then the LEED organization is basically divided into these categories. So we start with the location and transportation. We have also the sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environment quality, followed by innovation and design. And we're going to see also some additional points in the innovation and design. And in some of these points go through the green infrastructure and awareness, education awareness, and neighborhood and pattern and design. And basically the rating system structure is divided into 2 segments. The first segment is basically if the credits category has a prerequisite. So we must apply the prerequisite first in order to collect more credits and in order to qualify for the certificate. So the prerequisite is a must. Underneath the prerequisites, we're going to have options and cases or cases. So we apply all of those requirements to achieve those prerequisites. Then comes the credits. So the number of credits allocated basically tells us the level of certification. And the same thing happens here where we have options or cases, and fulfilling those requirements will achieve those credits. This shows the point distribution for new construction and major innovation. So the distribution of points and the allocation of the weights of the credits differ from one system to the other, but this is under the LEED version 4. And the number of credits allocated to each certification level, they start from 40 to 49 for the basic level certified, and then 50 to 59 for the silver, 60 to 79 for gold, and 80 points and above for the LEED platinum. Again, this is a very basic question that comes into the LEED credentialing exam. And it's also important to know what is the difference or what is the Green Business Certification Inc. stand for. And basically the US Green Building Council and the GBCI are both the same organization. The certification happens in different processes under GBCI. So we start with the commercial phase or the commercial type, where we have the starting period of the building to identify different partners, different stakeholders. This is where we have the lead charrettes, we have the groups, we have the brainstorming sessions happening. And then we register the project on LEED Online, build the project team, who's going to be responsible for which credits and which points. Look for the incentives. We're going to talk about these very basically, and then start basically the LEED documentation and design process. So the design begins with completing all of the design category credit in the categories, assemble documentation, GBCI conducts design review, and then we have three stages of rulings. Either it is anticipated, it's pending, or it's denied, followed by the construction phase. And the construction has construction credits underneath the system itself. So we need to complete the construction documentation, assemble all of the documentation, where the GBCI conducts construction review, and then the verdict comes to awarded, pending, or denied. Finally, you have the certification, where you secure the LEED flake, conduct occupant survey, and consider LEED for existing building operation and maintenance. So this is for the commercial process. Again, this definition of the process also normally comes as a question. So what's the process of commercial buildings, and what's the difference between the process of commercial and homes? So there's a big difference between the two types. We have an early planning stage in the homes process, where we basically set the project goals, and then this is something different than the previous one. In the homes, we need to select a LEED for home provider, where also we need to register with USGBC, build the project team, identify incentives, and then basically begin with similar to the commercial phase, design, construction. But here we have something different. We have third-party verification. So we need to get a green rater who completes all the project verifications. And then when we apply for certification, the green rater prepares a submittal package. The provider reviews submittal package. So these two are different than the commercial one. Then after the submission, USGBC reviews and certifies the projects. And then we need to also train and hand off to occupants. So depending on different types of construction and different types of LEEDs, there are certification tools, and they are available on the website, usgbc.org. This shows you the reference guide for building design and construction, and then the different types, for example, neighborhood development, operation maintenance. All of those are also available to use on the different projects. There's also certification tools where we can use as a checklist for LEED projects to help us identify the different points that we can collect. And of course, LEED Online is the main source where the project gets to upload all of the documents, have all of the team members assign tasks on it, and submit it for GBCI review. So everything happens through LEED Online. And now more than ever, LEED is global. So we are going to see that in different examples, different case studies while we go today and tomorrow. The important thing is to think of the integrative process. As we said, that's the main difference between what we practice normally and what is defined by a green building. And basically, it's in the very beginning stages, because it will help us establishing an iterative process. So the iterative process is basically something that we go back and forth until we reach the goals that we have designed in the very beginning. So synergize is very important. We're going to see that throughout this presentation and tomorrow as well. So we need to establish goals, brainstorm to make sure all of the goals work in harmony with each of the other stakeholders. where we want to research and refine the goals with different parameters, different techniques, different tools. And then look how that synergizes with different categories, different LEED credits, and then implement it, and so on. So the circle really kind of keeps on going, and that happens through something called the LEED charrettes. So the LEED charrette definition is basically the team selection that will basically help process the LEED point allocation system and define the stakeholders who's going to be with us on the team. It's very important to set the goals in the very beginning where we achieve the owner program requirements and make sure that we are reaching all of the thresholds and all of the prerequisites. And that's where we need to also observe different systems. So for example, if we observe one HVAC system, we can compare it with another one which might be at a higher efficiency, which can achieve better outcomes and so on. So that's where we need to also explore and select different technologies, different strategies to make sure the goals are met at a sustainable practice, and even thinking of lowering the cost in the selection stage and also in the implementation. So how are we going to implement the process? How are we going to build? How are we going to design? How are we going to operate later on? And it's very important to think of the operation because ongoing performance is very important to make sure that the systems that I have designed and built are really working as per the design and the construction properties. So I'm not going to include something in the building that tells me in the design it's going to do something, while when it's operating, it's telling me something else. So it's very important to really continue performance measuring. So they're saying here that you can't manage what you don't measure. So it's very important to continue measuring the performance throughout the life cycle of the building, and we're going to see the importance of that in different categories while we go through the presentation. So the basic information as defined by the integrative process as a conclusion for this part of the slides is to support high performance, cost effective project outcomes through an early analysis of the interrelationships among systems. So we are, in a project are going to be one team with one goal to achieve a high performance green building. Everyone's input is valued and considered. So every stakeholder in the team is valued and considered their points. It's obviously a learning opportunities for all, and lowering our operating costs and improved indoor environment quality for the occupants is something as a positive result from all of the integrated process and the synergizing happening with all of the credits. So that's basically kind of the first module. So we're going to see different modules. This was the first one as an introduction to what is green building, what is market transformation, how do we transform from a conventional market to a green building market, what is an integrative approach, and why is it important. So we're going to continue. If you have any questions on the first module, please post it on the chat box, and then we're going to have it later on. So we're going to begin with the first category, which is location and transportation. It's important to think about it because when you think of transportation and its connection to buildings, so what are some ways that location of a LEED certified building can reduce greenhouse gas emission? So that's the first thing when we think of the relationship between transportation and the building itself, is the greenhouse gas emissions. So if you remember back where we talked about the goals of the LEED system, the first one was regarding global warming and climate change. So this is where it really plays an effect. So what we're going to look at, we're going to basically describe the intent of the credit category. We're going to define the basic concepts and terms, and we're going to look at some examples of best practice. So the intent of location transportation is basically to develop in a compact way and in a smart way, so compact development. Alternative transportation, so we're going to look at how different alternative transportation really affects a project in a global climate, global warming perspective, and how it can achieve points in LEED. Connection with amenities, we're going to see that and how it's affecting different categories such as sustainable sites, using existing infrastructure, walking and bicycling distance, parking capacity, and preferred parking. So we're going to generally cover all of these points. So to begin with, for compact development, the first thing to really think about when you're building a LEED project is try to think of a smart location. So a smart location here basically refers to the best location of the building where it's going to be serviced by the majority of services needed by the occupants. So when we talk about smart location, we talk about having it in close proximity to services, having it in close proximity to current and existing infrastructure, different transportation modes and methods. So the smart location is a big added value here, where it's going to be affecting different categories in the system. So we're going to look also at the infrastructure and how it's important, basically to build a project within an existing infrastructure and try to avoid building on virgin land or sensitive land. So third point here says sensitive land protection. So it's very important also to think when we select this project site is to do an analysis of the site and see if this is defined by the government as a sensitive land, and if there are any habitats, ecosystems that are available there, we need to protect. So as concepts go for this category, so the concepts basically begin with limiting parking spaces. So limiting parking spaces is basically to minimum load allowed by code to avoid impermeable parking lots. So it's basically what is defined by the code, and apply the code to really apply LEED. So it's very important in the parking spaces. Some people come to me and said, how can I limit the parking spaces, and it's specified under LEED, while the municipality or the code tells me I need to provide parking for each resident, for example. So it's very important to apply the code, apply the regulations that are available before you really go for LEED. And then when you apply LEED, you try to minimize the amount of parking spaces, basically to go back to the system goals where we discussed the climate change effect. So limiting parking spaces basically will enforce and make people think before they really use their individual cars. So if you're going to a shopping mall and you know you're going to find some problems in parking, then you're going to think of using a bus or using public transportation. So that's the main idea behind limiting parking spaces. And underneath that, underneath the parking issue, then we have preferred parking. We have also parking for alternative transportation in cars, such as hydroelectric and so on. The site also has to have access to quality transportation and transit. So if you have the site that is located near or in front of an existing transportation infrastructure, such as a bus transit, such as trains and so on, those are points that can be allocated towards the building. In addition, you can have points to install bicycle facilities. Now there's a difference here using bicycle facilities in residential units and the difference in commercial buildings. Alternative transportation facilities, basically it can include, for example, bicycling, walking pathways, alternative transportation such as low emitting and fuel efficient vehicles. So overall, we're looking at reducing pollution and resource use impacts associated with automobiles. That's kind of like the summary of the transportation part of this category. The selection also is very important of a site. In addition to being in a smart location, it's trying to use current existing buildings where they are classified as brownfield sites. And here it's stated that this site is a high priority site. So a high priority site, basically here is a brownfield site where it's defined as a site where it was previously developed. It's in an existing infrastructure location within the city parameters, but was used for example, industrial purposes, where it was a workshop, where it was a manufacturing or something like that, and it's been abandoned. So the first owner, where it was an industrial building, left it where it might have some chemicals, some pollution within the site. So it's basically we're selecting a high priority site brownfield and transforming it to a green building by clearing all of the contamination and changing the brownfield into a clean, healthy environment. So this is just as an example of the same site, but how it used to look before we took it and cleaned it from its contamination and reused it in this part of the city. So that's the best case scenario for selecting a building and a site, is to select, this is considered to be a smart location because it's within infrastructure, it's within the city limits, and it has close proximity to different purposes and services as well. This is an example where this building is located near public transportation, and it's located in an already densely developed area. So this building will not have a real implication on infrastructure on the government to supply this building with electricity, for example, or sewage. So that's basically kind of covering in general the first module, which is in the category of location and transportation. So we began with introduction to green building. Then this module discussed the location and transportation. So basically we looked at how can location result in less greenhouse gas emissions and make your building more green, and think of what are some sustainable building location characteristics. So in these questions, these are basically something that you can keep in your mind and think of while we go through this presentation. And then tomorrow when we have the detailed session, you're going to know some more detail on how to answer these questions and how they be impacted on the credentialing exam. Okay, so do we have any questions so far, Deepti?
Hi, we have one question. When does the LEED GA version 4.1 expect to be updated? Until when can we take the exam with the current version is the first question.
So basically, the update for the exam has not been announced. It's going to be announced on the website. So similar to the update on the exam taking policies have been updated on the website. So the exam for the LEED credential is going to be still under LEED version 4 until basically we start advertising for it maybe next year.
Right. And then there's another question about a residential project. So there is a different category for residential in version 4 home and now residential. But in BDC type, there is indicated as multifamily apartment, low-rise, condominium in anticipated type. Also, the buildings are built with library, facility management offices, pool, meeting rooms, playrooms, etc. In fact, that it could be chosen mixed use in version 3, but now what do you suggest about the residential? Should they do residential BD plus C or multifamily apartment? Yeah, that's a very interesting question. I'll take it. With the evolution of LEED version 4 homes, we've now launched LEED version 4.1 residential, as you've correctly mentioned. For the Middle East, we are following a different approach. from the standard international approach. So we are basically trying to learn from pilot projects and see what option best works for the Middle East market. So if there is a specific query, I cannot directly answer this question now because I don't know what kind of project you're looking at, but please send us an email and we'll be very happy to support you. I think that's it for now. We just have two. Yeah. So there is one question on how to become LEED faculty, which is USGBC faculty. And then another question on what is the difference between green and sustainable. Yeah.
Okay. So in terms of USGBC faculty, there's an online application for it. And basically, the minimum requirement is you have to have experience in education and the education sector through, for example, workshop giving, lectures, seminars, webinars, anything that has evidence to show your expertise in the education section and in the education industry, and basically also to have a minimum of a LEED AP credential with you. But please, log into the website. There's a section for the USGBC faculty application. All of the rules and all of the instructions are available there. But I can say that the two main requirements that are needed for obtaining the USGBC faculty, and then it goes through a review process, which might take some time, and then you get kind of a basic interview from our directors in the USGBC faculty department. The second question on the difference between green building and sustainability. Sustainability, when we talk about it in general, based on the triple bottom line of social, environmental, and economy. On green buildings, when we talk about it here, we talk about it in detail in different segments and different sectors. So you're going to see probably an answer to your question by the end of today, and even further when we talk about it tomorrow. So I want to move on forward and probably cover a couple of sections here before I take further questions. So the sustainable site category, you're going to see it's very linked closely to the location and transportation. So when you think of the site itself, what are some ways selection of a building location and building orientation can reduce environmental impacts of a facility? So, for example, if we think of the building orientation, can it harvest nature's energy and reduce heating, cooling, lighting loads? And selecting a location with open spaces can allow natural habitat construction, restoration. A site large enough to manage rainwater will recharge the local aquifer and reduce or eliminate the need for stormwater piping and infrastructure. So many items and issues can go underneath the appropriate selection of a site and really developing it as a sustainable site. So we're going to talk about here in this module on the description of the intent of the credit category here, definition of the basic concepts and terms, and recognizing examples of best practice. So the topics here we're going to cover are very basic, very general, and then further details will be discussed in our session tomorrow. The intent of the sustainable site is basically to analyze the relationship between site and the proposed facility. So similar to the location transportation, where we analyze the location of the building with different aspects such as the site of different services, infrastructure, and so on. Over here, also, the other intent is to restore the project site to its natural elements. Also, we need to preserve the biodiversity and integrate the site with local and regional ecosystems. So some of the concepts of building location is the first thing to do, conduct a site assessment. That's very important because that will tell us the different environmental impacts on the building, such as the wind direction, solar orientation, how can we benefit from passive cooling, passive design, all of those items that we can do in the analysis phase, where it can reduce my reliance on mechanical systems to provide me for cooling and heating, for example. The other concept is to protect or restore habitat. So an analysis can be done to really evaluate the site and see what habitats are available either close by or within the site that have been previously there and have gone. So this point here, this credit, it's something that can be done on sites where you know, they have the option of really looking into the different habitats, different ecosystems that have been previously was there but have gone, maybe to the demolition or construction practices or something like that. The final concept is to really integrate open spaces and link open spaces to the building. So two things is to link the building to open spaces nearby and also integrate open spaces within the building as much as possible if we have the option to do that. Also, on the site itself, we want to also look at rainwater management. Now, that's a point that we're going to look into detail tomorrow, but in general, the site can have different and multiple advantages from integrating rainwater management into the site, even though the site might not have rain for quite some time in the year. But rainwater management is an added value to the site to have it as an infrastructure built within the site. The second point here is heat island reduction. So heat island basically refers to the amount of heat absorbed by the construction or absorbed by the city, absorbed by the buildings, the streets, the pavement, all of that heat hitting those surfaces during daytime and then released back into the environment, back into the sky during nighttime. So what happens is you have an increase in temperature during nighttime compared to the same city, but without construction, without buildings. So the same city might have an open space, a rural space where you don't have much buildings. You're going to see different temperatures during nighttime because of the heat island effect. So the site itself can help us reduce heat island effects, and we're going to see different detailed strategies tomorrow. The building orientation is very important, and it's also helping us in achieving a sustainable site, especially when we conduct a thorough analysis in the very beginning of the stages of the design, to help us really use the site either from the orientation perspective or use the adjacent structures to really help me reduce the heat load going through the building, or also the cooling load that I need to cool the building if I need to. The final point here is light pollution reduction. So you might see here in the picture up here where you can see all of the light pollution coming out of these buildings. Basically, what comes out and above is not needed. So all of these buildings are paying for lights that are lighting the sky where they don't need them. So basically, light pollution reduction, you can think of it in two ways, in an economical perspective and an environmental perspective. So economical is basically you're going to reduce your overall cost by reducing and fixing the light to tasks where you need them, and not something like this where you have waste of light going to the sky. And in an environmental perspective, you're going to have reduced lighting pollution and preserve the dark sky initiative, where you can actually see a dark sky and see stars during nighttime and preserve the biodiversity that are living close by. Some of the best practice in the sustainable site category is basically having a high performance building location. So a high performance building location basically reduces urban sprawl. So there's a concept that basically says, instead of going out, building in a horizontal perspective, that's the urban sprawl, try to compact it. We talked about compact development in the location transportation. So compact development can also mean reducing the sprawl, reducing the expansion of the city. So instead of building out, try to build up. Now, I know some people might say that the regulations in the city don't permit us to build up, but still there's permission to build at a certain level and a certain height. So that's a sustainable selection there, is to reduce the urban sprawl, encourages healthy living. So a high performance building location will encourage people to live in a healthy living lifestyle. It also protects threatened species. So we know now that, due to the lockdown, due to people staying in home, we saw some images spreading around in social media where lifestyle have changed a lot to permit, natural species, animals coming out to explore the city and explore everything. So the species that are around us, we need to protect them as much as possible, and we can do that with high performance building locations and also preserve agricultural land. So when we limit the urban sprawl, when we limit the expansion in a horizontal way, we will preserve agricultural land and make sure that the land we will use for expansion will not be really demolished and will still be a natural habitat for different species. Some of the best practices here for a building site and high performance building is really manages stormwater. So even though some sites might not have huge amounts of rain over the year, but still a high performance building site needs to manage stormwater. It also restores contaminated sites. So we saw that in the location transportation point, where we can select a previously developed site that was considered to be a brownfield, where it was probably used to be an industrial facility for manufacturing or for car workshop or something like that, where it had some oils, some waste and something like that. Protects habitats, and finally reduces excessive heat and light. So when it's designed properly, we will see different approaches tomorrow to reduce basically the heat island effect and reduce light pollution. So basically, that's kind of like a summary of the sustainable site category. Two questions here to keep thinking of until we come back tomorrow in detail. How can location make your building more green? So it's very important here to think of this, and especially for people who still have an option to select a location of their building. If the location is not an option to think of, some people have their locations fixed, maybe as an owner or as an investor. Then there are ways to also incorporate sustainable aspects and green building aspects, especially for LEED in those sites. We're going to see that later on. The second question to think of is, what are some sustainable building site characteristics? So some of them we discussed them in the best practice high performance building sites. So in addition to that, think of this while we continue on the discussion in detail tomorrow. Okay. Okay. The water efficiency credit category. If you go back and if you refer back to the goals we set in the very beginning of the goals for LEED, basically the water efficiency comes right after the climate change, global warming, and preserving the biodiversity. So when we think of it, also we're going to talk about it in terms of what is the intent of the credit category, how to define the basic concepts and terms, and we're going to see some best practices for this category. So this is in general review. So a few things here as an intent for this category is basically to reduce water as much as possible, and reducing water in different manners, different ways. First is how to reduce indoor water use, outdoor water use, and then cooling tower water use, finally metering and monitoring. So we're going to look at all of these four. So it's very important when we think of water use is to think in it in different ways we use water. So indoors and outdoors. And in addition to that, we use water for different systems to cool down air conditioning and so on, and for processed water for manufacturing and so on. So for indoor water use efficiency, so think of where the indoor water use is being used, and think of the purpose of that water use. Can we use gray water? And is it allowed by code? So some people, some countries or some cities or some locations might have restrictions on where to use gray water. So it's very important to follow that code. And then after the code permits it, then we use it in LEED, and we use it as points in this category. And in addition to the identifying where we can use gray water, it's also important to have a building level water metering. So it's very important because this is the prerequisite, is to have a building level water metering. And then if we have large building, for example, where we can have an option to use sub-metering for different sections, for example, different floors, different buildings. We might have buildings that have, for example, different towers, where we also have different systems for indoors and outdoors. So it's different from one building to the other, but basically as a prerequisite is to have a building level water metering. If we go back to the previous, to the first module, we talked about the performance. One of the ways to make sure that the system here works for the water efficiency is to really monitor the water use. And over here, this slide shows it's important to monitor the indoor water use. Same thing in the water category is basically to monitor and make sure my outdoor water use is efficient. The different water use for outdoors, basically, for example, is for landscaping, cooling tower use, ponds, and rainwater capture. So ponds and rainwater capture can help me in using the water efficiently, reducing the demand on potable water. So that's the main purpose here, is to reduce the potable water use as much as possible. So for outdoor irrigation, for example, if it's allowed by code, then certainly 100% use non-potable water. Some of the best practices, basically, most of us are doing it anyways, either due to the regulations and the codes, or that the fixtures available now in the market are considered to be high efficient fixtures. So the first point for best practices in water efficiency is to install high efficiency fixtures and appliances. Second, eliminate reduced water used for landscape. So this can be done by selecting appropriate landscape that needs less water, less maintenance. The third, install systems to utilize non-potable water where possible and allowed. So that's very important, is to go back and refer to the code if it's allowed to use non-potable water, and use it as much as possible to reduce your potable water use. The fourth is to monitor water use. It's very important because you need to check based on the goals and objectives that you set in the very beginning. And how can you make sure of that is basically to keep monitoring your water use. Finally, establish process for improving performance over time. So even though we are still keeping performance at the level we set goals in the very beginning, but there's nothing to stop us from establishing a process where we can improve the performance and increase the efficiency. So that's a way where we can be more innovative and exceed what we actually started with. This is a case study as an example. Basically, we're going to see some details more in tomorrow's session. This example, the Manor Bank building uses 80% less water than conventional buildings. Now, the building uses different systems. So, for example, they used system to capture stormwater from streets and parking lots. So the surrounding streets, the surrounding parking lots, they've used the rainwater collected there to the site and use them in different purposes such as irrigation and toilets. They also, stormwater along with reused gray water is used to flush toilets, and they have low flush toilets and urinals. So these are some basic level kind of strategies to use for best practice buildings, and many more practices. We're going to see it in detail later on. So that's basically in general kind of tapping into the water efficiency category. Four things here are a must and important. First is to look at the indoor water use, and then the outdoor water use, and then the cooling tower water use and the process water. And finally, monitoring and making sure the performance is as designed and as built. In the case for this category, there are some set goals that we need to follow. Two questions here to keep in your mind and think of. First one says, what are 3 ways you can improve a building's water efficiency? Now we saw some case best practices here. You can basically identify those 3 ways. Second question here, what water efficiency strategies are you using at home or in your workplace? Now, as I said, the current practices are much, much better than a few years back. Most of the regulations here, either in Saudi Arabia or in different GCC countries in Middle East, basically are being improved to be very high efficient in water, because our region is really a scarce water region where we need to really focus on this category. So I hope that gives you kind of an overview of the water category, and we're going to talk in detail regarding the different credits in this category, and helping you and guide you for the credential exam in tomorrow's session. Okay. Any questions, Deepti? Or?
Nothing till now. That's it. I think we can take a quick break. Yeah.
Okay, good. So I'm going to continue. So the energy and atmosphere category is the heaviest and the most points allocated in the LEED system. It's also implicating and in synergy with different categories, such as the location and the sustainable sites category. So if you remember, we talked about the location and also the orientation of the building. So designing in a perfect way where you take advantage of the location of the site, take advantage of the orientation of the site, calculate the different angles where the sun comes in, where the wind comes from. All of that really has an effect on this category. And this is one of the points where you can collect as much points as you can. These types of questions are basically normal to the LEED exam. So this is one example. It says, what percentage of US carbon dioxide emissions is associated with the use of liquid fuel and electricity by buildings? So basically the question here answered by this C is 39%. So these questions will have guides on how to answer them. I'm going to share some details when we continue on our session tomorrow. But basically what we're going to talk about here is, again, we're going to look at the different intents of this credit category, and we're going to identify the basic concepts and terms used in this category, and we're going to look at best practices. So it's very basic here. From the definition of this category is basically to have an energy efficient building. And we can do that through energy use reduction, energy efficient design, and also renewable energy. Now we're going to look at these in very basic definitions. And when we think of the energy use, there are different ways where we use energy in the building. Similar to the water efficiency category, where we have water use either indoors, outdoors, or in the process on cooling towers. So over here in the energy use, we will look at the intents where we use them in building design and energy performance. So how can the design of the building really help me reduce my energy consumption without really applying any technology, without any costs? So that's the first step we need to think of here. And this is kind of like the general definition of it in this category. The second point, the energy systems commissioning. Similar to any system we install in the building, where we either select it in the very basic level in the design phase or in the concept phase, where we select them to help us reduce our overall consumption, either in water, energy, or whatever system. So it's very important to commission, to test those building systems. And specifically here in the energy system, it's very important because most of the faults that generally come from the building when we use them, when we operate them, is there are some glitches, some problems, shorts coming in from the building, electrical systems, and so on. So it's very important here to really commission all of the systems we're going to use. The third point, refrigerant management. So the refrigerants are key here to the cooling systems we use in the building. So when we talk about refrigerants here, as the chemicals we use to cool down the air. And it's very important to know which types of refrigerants we use, because some of them now are banned or prohibited to use by something we call the Montreal Protocol. And the selection of the refrigerants basically have a direct impact on the global warming potential and the ozone depletion potential. We're going to see those definitions tomorrow when we talk about them in detail. Before last, we talked about the monitoring and verification. Again, it's important when we commission the systems, when we finish the commissioning and testing all of the systems, is to make sure they perform and work as we intended them to do so. So if we design a building that has to achieve 30% less energy use than normal buildings, that we need to really test it, and we need to make sure in the performance measurement system that the building really achieves that goal. So monitoring and verification is very important. And finally, the demand response. So basically, we need to participate and implement demand response technologies and programs that make energy generation distribution systems more efficient, increase grid reliability, and reduce greenhouse gas emissions. And we're going to see that also in detail in our session tomorrow. In terms of energy supply, two things here are identified under this category. Basically, the first one is to try to generate on-site renewable energy, be it wind, solar, geothermal, any of those renewable energy sources. If I can have the option to have it on site, that's the best case scenario. If there's no way to do it on site, then we still have the option of benefiting from renewable sources, but it's going to be off-site. So that's the second point here, is to have green power and carbon offset. So green power also is defined, we're going to see that in detail tomorrow, in two ways. Either we purchase green power immediately from the utility provider, or if the utility provider doesn't provide the consumer or the client with direct green power, then we can have the option of purchasing renewable energy certificates. Basically, from this point here, from this credit, what we want to achieve at the end is basically offsetting my carbon emissions of the building. So when we offset the carbon emission of this building, it will help us in offsetting carbon emissions at a global scale as well. Okay. Some of the best practices here in the energy and atmosphere is basically, the first one is to reduce energy demand. So we need to also, when we think of the design in the very beginning, when we have the stakeholders with us, if you remember the example we said about the HVAC system and the window system, the insulation, that's a very basic example of where it will have a heavy impact on the energy section here. So reducing energy demand is the first point to think of. Increase energy efficiency. So we nowadays, for example, focus on LED lighting, high efficient fixtures, daylight sensors, for example. So it's different methods that we use in the building that can help us really achieve the goals of energy efficiency. Generate on-site renewable energy as much as possible. So even if it's a small amount, it can still be an advantage for the building. If we don't have the option of on-site renewable energy, then we have the option of purchasing green power. And that can be done through different organizations where you purchase a green power certificate or renewable energy certificate. ensure the systems function as designed. This is very important, and this is one of the prerequisites, one of the crucial points, is to commission the building at a minimum, to have it a late commissioning stage, where you basically commission the building during the construction stage and before submitting the building to be used by the owner and the users. So it's very important to ensure that the systems really function as per the set goals in the very beginning of the building design. And also to monitor performance over time. And this will also lead us to make changes to be a better performing building, and possibly even go for the LEED certification for operation and maintenance. So if we have a set of procedures where we can have monitoring of the performance over time, such as BMS systems and everything that we can use as smart technology, then that will help us also make sure the building is performing as we designed it and better. A brief example here, this building, this house uses 30% decrease in energy when compared to conventional building. It has 100% Energy Star rated appliances. So that's one of the points here, and that we can use nowadays, as we can find Energy Star rated appliances abundantly in the market. That's the first choice to go to. Efficient sealed combustion boilers. So that will make sure that the combustion boilers work at a low level of energy consumption because there's no leakage. And in addition to that, you can also make sure that the building is airtight, sealed, so you don't have any leakage in that building as well. And this house also used efficient lighting fixtures. And nowadays it's very common, it's the normal practice to use LED lighting and efficient fixtures. Okay, so these questions here again is basically kind of a review for this module that we talked about in terms of the energy and atmosphere, and also something to keep in your mind to think of today. What are measures of building energy efficiency? So that's the first question. The second, what examples of on-site renewable energy have you encountered in your work and life? So we might see some examples when we talk about it tomorrow, and more than welcome to share with us your feedback on the chat box. Finally, what is green power? So we mentioned in the previous slides that we have two options of green power. Either it's on-site renewable energy, or if it's an off-site, then we have the option also to purchase green power from off-site sources. So that's basically a general overview of the energy and atmosphere module. So I'm going to continue on with the materials and resources. Okay. So one of the items also that you might want to focus on are also, in addition to the titles of the categories, you need to also consider the logos of the categories. So this will help you really basically identify in a clear way which category we're talking about. So it's very basic, it's very self-explanatory. So the materials and resources, this is a question that also sets you in the right mode for this category. No other industry in China and United States uses more materials by weight than the construction industry. So just to move on, this is actually true. So the construction industry in China and the United States has, the most weight compared to other countries in the world. So for this module, we're going to look at, again, the same construction of the different modules we talked about, the intent of the credit categories, what are the basic concepts and terms used in this category, and what are the best practices. So the first thing that we think of, and similar to the energy and water categories, is reduction. So there are 3 R's that we're going to use here in this category, and we should use them in our life as well. Reduce, reuse, recycle. So the 3 R's. The first one is reduce, and we can use these 3 R's in our life in different perspectives. But in the LEED here in this material and resource category, the first thing is we try to reduce the amount of materials needed. So before even considering using which type of material for which type of building and which section of the building, we need to keep in our mind and set our minds on reducing the amount of materials needed because that will help us later on in the cost. That is from the financial perspective, but from the environmental perspective, we're going to reduce our demand on non-renewable sources, and we're going to reduce the demand on sources that are not available in the markets, and we need to bring them from offshore. So that brings us to the second point: is try to use materials with less environmental impact. Now we're going to look at this in detail tomorrow, but generally here we talk about materials where it has less environmental impact by knowing the ingredients of the materials we're using in the building. So it's very important when you think of a material, when you're purchasing a material, is try to purchase using a sustainable purchasing procedure and policy. So basically there's a certificate for material which is called the EPD certificate, which is the Environmental Product Declaration. So some manufacturers disclose what is the environmental impact of their product, and they get a certification from a third-party verification body. So that's the best case scenario, is to select a material with an EPD. That's kind of what we want to focus here. I'm going to show you some detail on the next slide. The final point of the intent of the material and resource category is to reduce and manage waste. So as you see, again, we want to reduce before we even make waste. And if we have waste, how can we manage it in a sustainable way and actually benefit from the waste generated on site? And try to avoid the waste going to landfill. So the main concept here in this category is basically one of the main concepts is the EPDs, and it's called the Environmental Product Declarations. So basically different stages of the material go through different life cycles. So basically we can think of it in this way. The lead charrette or the lead team sits in the very beginning of the project, thinks of a concept, thinks of the concept where they want to use certain types of material in the building. And based on that, they start designing the type of material they're going to use for that type of building and so on. Then they start extracting the material as raw material from the source of the material. So whether it's onshore, close by, close proximity, or if it's offshore, far away, that will really have an impact on the footprint of the product. So basically, it's very important to think of the locality of the material because the close proximity of the building material means you have less footprint effect as a negative effect on the environment, in addition to having less effect on the economical side, because you're going to have less fees for transportation, less fees for raw material extraction. So anyhow, you take the material from its main source, then we transport it to the manufacturer where we have it manufactured to our design specification. Then it gets transported to retail shops for consumer use. We go and buy the material, transport it to the site, use it, and then dispose of it after it's used. That's kind of like the normal cycle of the building material. And we call this cycle from beginning to end, we call it the cradle to grave. So the cradle basically starts with where the material is extracted from. The grave is basically where it's going to landfill. So this is the conventional cycle of a building material where we want to reduce this cycle. We want to have a cycle called cradle to cradle. And we're going to see it in detail tomorrow. So this is why it's important to conduct a life cycle assessment. So the life cycle assessment is basically an environmental assessment of the building material to help us make the decision if this material really helps me reduce my footprint, ecological footprint or not. So the footprint is not health effects. So it's a footprint in terms of ecological perspective, environmental perspective. The life cycle assessment, or short LCA, must follow standard ISO requirements. So we're going to see throughout the slides some standards, international standards we use. So for example, we use ASHRAE, we use ISO, we use different material standards here, such as Green Seal, Green Label Plus, FSC. Many of these terminologies, we're going to see it in our second form. Okay. In addition to the EPD, the Environmental Product Declaration, we have another thing that we can opt to go for, which is the Health Product Declaration, or HPD. Basically, this tells us the potential health effect of a product. So in addition to the EPD, where it tells us the effects of a material on the environment, we can have an additional certification here for the building material to basically tell us what is the health effect of that building material on the user. And this basically can be as a list. So we can define it as a red list of bad chemicals. And manufacturers basically must disclose what is in their product. And this can help us make our decisions in the very early stages of the building to make decisions on the healthy products we're going to use, even in cleaning products. We go to the operation of the building. If we have the HPD, then we can select the cleaning products that can be considered as green cleaning products. Now, different organizations have different lists of these declarations. You can find here the Health Product Declaration Collaborative organization. You can access their website and see some more information on it. Okay, some of the best practices for the materials and resources is basically, in addition to the first point we talked about in reducing the material, that can be done through reusing existing structures and materials. So if you remember, we talked about the brownfield and using existing buildings. That's a big bonus here when we talk about it in this category. So because we are using an existing structure, we're not introducing something new to the site. So we are reducing the amount of material used on that site in a very efficient way. In addition to the structure itself, we can reuse material either from the same building or from different sites. We can purchase recycled material to be used on site. The second point is to reduce construction waste generation. So it's very important in the design phase to really design the material that's going to be used for the construction in a very specific manner, so we don't have waste generated from the construction. And then the point after that, if we have construction waste, then how can we recycle the construction waste? So the whole point of it is really to eliminate and reduce the waste going to landfill. Finally, select non-toxic, recycled, or rapidly renewable material. So the point of the EPDs and HPDs is basically to think of the material that has less environmental impact, has no toxics in them. In addition to that, selecting material that can be rapidly renewable within a few years, not selecting material that needs hundreds of years to be regenerated. An example here, such as the California EPA headquarters, $80,000 per year saved with reusable cloth recycling bags. And the construction materials salvaged or refurbished here are used. Purchase recycled material, so that's an added points here that they used recycled material from offsite, so they purchased it. And they use certified wood-based material. So FSC certified wood, which is the Forest Stewardship Council. That's a third-party verification body where they certify the wood material is from a sustainable source and manufactured in a sustainable way. So those are some of the key points here in the materials and resource section. where basically we think of the whole material selection of the building to be used efficiently and basically to reduce the amount of material needed and eventually reduce the amount of waste generated and going offsite to landfill. Two questions here to think of by the end of this module. Why can the selection of sustainable material on a building project have a significant influence? So we talked about this in general here in this module, and again, we're going to see it in detail in our session tomorrow. The second question, what are some sustainable materials you have in your home? One of the basic materials that I usually see in homes, offices, is FSC certified material. It's very basic. You can see it everywhere nowadays. So think of this and share with us your ideas. What do you have in your home? What do you have in your office that is considered to be sustainable material? So that's it for this material, for this category. So we're going to move on to the indoor environment quality. Deepti, any feedback, any questions, or should we continue?
There's a question on, is there any best practice in energy and atmosphere in Saudi? And also there's a question on ASHRAE 90.1 2016 energy modeling. So what they're asking is the energy modeling software do not update according to 90.1. What do you suggest for energy modeling methods or other options? So to the best of our knowledge, IES is adaptable, and there are also other softwares that are now aligning themselves slowly to the 90.1 2016, the latest requirements of LEED. So if there's a detailed question, please email us and we'll get back to you specifically on the doubt itself. And then the second question is on any best practice in energy and atmosphere in Saudi Arabia. Like, how does one go about with this credit category is what they're asking.
So basically, you know, to make it short for today's session, is some of the best practice we see in Saudi is following the SASO regulation, Saudi Authority for Standardization, اللي هي in Arabic هيئة مواصفات المقاييس. So basically using energy efficient fixtures, improving daylight quality through passive design techniques and so on. So there are many different best practices that can be used here in Saudi or in any region for that matter. We're going to see that in detail tomorrow. We're going to discuss some case studies from Saudi. In addition to some, you know, the projects that's considered to be case studies in Saudi that have been awarded LEED for different levels, silver, gold, and platinum. But generally, when we talk about it, we talk about, you know, reducing the energy efficiency, reducing the energy, you know, cost and the energy amount used in the building. So how we do that, it's very basic. It's very, you know, common to sense to, you know, use daylight as much as possible. There are many strategies also to use that for internal spaces that don't have the option of outdoor views. So all of that, we're going to see it in detail in tomorrow's session, inshallah. Okay. Okay, so moving on, we're going to talk about the indoor environment quality. And you're going to see some interconnection here between this category and the previous one, which is the materials and resources. Because basically the types of materials I'm selecting, where we talked about, for example, the EPD and HPD, Environmental Product Declaration, Health Product Declaration. If the material has been selected with environmental benefits, then it will have a positive impact on the indoor environment. If not, then it's the other way around. So a question here, basically similar to what comes in the credentialing exam. What is the most costly part of an existing commercial building? So before I answer this question, so let me see if I can do this. I see my cap. Okay, I couldn't do it. I wanted to see polls from your answers, but anyhow, the answer, which is not really, answered by most people who see this question. What is the most costly part of an existing commercial building? The answer is D, people who work in the building. So basically, it's shocking to know, to some of you, if you don't know this already, that about 90% of running a building as cost go is basically going towards the people using it. So you're paying salaries, you're paying health insurance, you're paying leave allowances, you're paying any source of money basically for people. And when we talk about the cost of building, and when we talk about this for different investors and different people who basically just think on the existing or the physical part of the building, one of the methods to convince people is basically to help them shift their thinking from the physical aspect of the building to the people using the buildings. And nowadays, there's, our USGBC president has launched what we call the USGBC version second generation. And basically, it's talking about people. And we have a campaign called the Living Standard campaign, where we talk about really stories of people rather than just the physical aspect. So that's something we can discuss later on. We think about it later. So again, we're going to talk about the intent of the credit categories. We're going to look at the basic concepts and terms, and also the best practices. So for the indoor environment quality, we talk about these different things to help us provide systems that ensure a quality of indoor environments that is high of quality, healthy quality, and make the people using the building really healthy, productive, and also in addition to being safe. This also ensures that we want to ensure air quality, thermal, and visual and acoustic comfort for the people using the building. And we're going to see some strategies here as best practices, which can help us really ensure this parameter. Finally, eliminate, reduce, and manage contaminants. So this really connects back to the materials section before. So where the really the choice of the material that we select will have a big impact on the quality of the indoor environment, either through the contaminants that emit from it. So we have something we call the VOC, volatile organic compound. So that's something to really consider here, to really select the material with less environmental impact, because it will help us improve the indoor environment quality of the building. Some strategies, basically, we can do it right away. This is something we also discussed in the sustainable site. And related to that, when we talked about this energy and atmosphere category, is the ventilation. So if we use good ventilation, passive techniques to use ventilation, it will help us reduce the overall load of energy use in our mechanical systems, HVAC systems. In addition to that, it will provide us with fresh air on a regular basis. So all of the contaminants, all of the VOC in the building itself will be flushed out. So using fresh air as much as possible is best practice here. In addition to that, it's important to make sure that thermal comfort is achieved throughout the whole building. So different people have different thermal comfort parameters. So there's a normal range where you need to, be within that range to make sure that the majority of the people using the building are comfortable in that perspective. Additionally, LEED buildings have shown, when opted to use and benefit from daylight and views, have shown increase in productivity, increase in health, increase in cognitive behavior of the people using the building. in addition to having less absenteeism and many other benefits that can be shared later on. We're going to see some details on it in our session tomorrow. So some of the methods really here to also help make sure that the indoor environment is controlled is to really make sure that you have an airtight sealed building, but the materials that you use to make the insulation and isolating the building really effective is to make sure that the materials you use are either certified by a third-party verification system or have EPDs and HPDs that we discussed previously. So contaminants that can come from building material, such as paints, sealant products, flooring systems, insulation, furniture, cleaning products. That's why I said, in the previous section, it's also important to think of the material you're going to use after the building is opened and operated. So the cleaning products can be selected to be green cleaning products because it will have a large impact on the people using the building. And nowadays, due to people being in lockdown, and especially in our houses, now we really kind of can value this point, especially here in the indoor environment quality, where you can evaluate and assess your house at this moment. Do you have efficient daylighting? Do you have efficient ventilation? And so on. So all of these points really can be, analyzed in the very beginning of the stages of the building, and it can start with using best practices such as passive design techniques for either heating and cooling, for ventilating. So some of the best practices here is to illuminate with daylight, but watch for glare. This is one of the points that is kind of like a two-edged sword, where you have to be careful not to increase the daylighting, where you're going to have glare and you're going to have heat transferred to the building. That's what we don't want. We don't need to control it, but at the same time, illuminate with daylighting because it has many health benefits. Second point is to offer views to a large fraction of the occupants. Again, this is a very important point here because it's important to link the physical body with the outside environment. And this has provided, many health benefits, and many research has shown, the benefits of really having a view, having an option to a view. And it doesn't matter that the view is, a forest or a lake or an ocean. No, the purpose here is to really just have a link to the outdoor environment. What's happening outdoors? Is it rainy? Is it sunny? And so on. Third point is to provide control over heat, light, and ventilation. So if the occupants really have control over, their comforts in the building, for example, in heating and lighting and ventilation level, that's also something that can increase the productivity of the people using the building and can give them a sense of control of the space that they use on a daily basis. Finally, prevent potential harmful indoor air quality contaminants. So that's why we said in the materials section is to select material with EPDs and HPDs, and also to select material that has been verified by third-party verification systems such as the Forest Stewardship Council, FSC, Green Seal, Green Label Plus, all of those systems. Those systems basically can help us in the selection of better indoor quality material that will reduce the contamination indoors. Some of the best case scenarios here, this is a case study where occupant comfort and minimize contaminants have been done through these strategies. First of all, floor-mounted air diffusing systems. They used low and no VOC paints. So VOC means volatile organic compounds. So they used paints with low and no VOC. So that's one of the choices that we can make in the building, is to really look for paints, look for material with no VOC. Or if there's no VOC, then choose the least VOC material as much as possible. This building used non-solvent based adhesives and also used low emitting carpeting. So the emission coming out of the carpets is very low. Walk-off mats to remove contaminants from footwear. So this is something also very important, and some people might neglect this portion of the building. It's very important to have this walk-off mats in the very big, entry level of the building, so to make sure that the footwear gets cleaned before the building, the people use the building or enter the building. That's one point here that this building really used, and it's considered to be best practice. So that's kind of the link between, thinking of the link between the materials and resource section and the indoor environment quality section. But we're going to have some more detail in terms of the credits underneath this section in our session tomorrow. And you're going to see this in a clear way better in the session tomorrow. So 2 questions here you might think of. Is it true or false that the design of a building alone can ensure healthy air quality? And of course, if you choose true, why or why not, and so on. Okay, so we're basically towards the end of this session. We're finished with the main categories of the LEED rating system version 4, and it's 100 points allocated for the credits, basically on the previous categories we discussed. There are 10 bonus points that can be allocated for innovation and design region priorities. So in terms of the innovation and design, from its name, it's something that we use as innovative in the building, which is basically either not classified under the LEED rating system, or we use something that basically exceeds what is there in the LEED system. Question here, is it possible for a new building to be carbon neutral? So something to think of. Again, we're going to look at the intent of the credit categories. We're going to look at basic concepts and terms and best practices. So as I said, basically the innovation and design, and even if you look at the logo, it's something that you think outside of the box. It recognizes exemplary or exceptional green building strategies. So something that is not defined under LEED, for example, something that is exceptional in terms of performance, and it rewards practices that LEED rating system does not specifically address. So if you apply something into the building that has not been addressed in LEED in all of its categories, it can be applied under the innovation and design category, and that's where you can have points allocated for that strategy. Some exemplary performance, for example, substantially exceed LEED requirements. So for example, if you have a certain percentage you should achieve in one of the categories and you exceed that in an exceptional and substantial way, you can ask for that to be allocated and counted for it in the innovation and design category. The second point for exceptional performance is address issues not covered by LEED. And finally, demonstrate comprehensive approaches and quantifiable benefits. So can the points that are used in the building be demonstrated in terms of comprehensive, and the approaches used can it be quantifiable? In addition to that, there can be a point allocated for having a LEED AP on the team. So LEED accredited professional can be applied here in the innovation and design. Basically, the purpose for this, or the benefit, that the LEED AP has to be a principal participant in the building design and construction process, who helps apply the LEED rating system and educate the project team. So having a LEED AP on the team is very beneficial. In addition to educating the team, that member can also streamline the process because they will be familiar with the LEED process and the different requirements and documents that need to be submitted. An example here for best case practice in this building, basically they exceeded the LEED requirements in the following areas. They have education programming, green cleaning, the commuting program, green power purchasing, construction waste management, local sourcing of materials, greenhouse gas reduction, and many more practices we can think of. For example, in this example, they have 71.4% of energy costs offset by renewable site generated energy. So they have renewable energy on site where they offsetted 71.4% of their costs. The second point they used here, they substantially exceeded LEED standards and addressed issues beyond the current system. And this building is completely carbon neutral. So this is the answer to the first question. Can a building be carbon neutral? Yes, it can. And you can actually go to the positive side, not just be neutral. And that's something we introduced in the LEED system where we talk about LEED positive. So basically, that's kind of like the final points in this session. Two things here to think of, true or false. Innovation and design credits must address an issue not covered by any other credit category. So is this true or false? Second question to think of, what are some areas where a project can exceed LEED requirements and receive innovation and design credits? Again, this question, these two questions, we're going to have the answer for them for you tomorrow, but something to think of while we complete our session today and share with you tomorrow. So as a summary, basically, hopefully you have a general understanding now of what is a green building, what is sustainability, what is the role of USGBC, and what is the LEED version 4 system. You should be able to recognize the intents of each LEED V4 credit category, explain key sustainability terms and concepts we use throughout this session, identify green building best practices in general terms, we discussed them today, examine cutting-edge examples. So we're going to look at these also in detail tomorrow. Example cost considerations, and recognize your role in green building. So hopefully you can have an answer for that, and you can share with us what do you think your role in green building can be. So in a summary, in addition to defining the different categories and the different credits under each category, it's important to think of these in synergy. So each category, each credit in these categories will have an impact on different categories and different credits. So synergies between these is very important. So for example, when we select a smart location where we use sustainable site practices, that can have a huge impact on the energy and atmosphere credit, water efficiency, even material and indoor environment quality. So all of those really have interconnections between each of the categories. Finally, it's important to think of incentives and recognition programs, either locally or internationally. So for example, if local regulations can have additional permits or speed up permits if you are a LEED certified building. So those are some of the things as an example. And basically achieve goals and requirements is given when you have all of these points achieved in LEED. For the LEED credential exam, there are many sources online, but here provided for you two examples here, the LEED Core Concept Guide and the LEED Green Associate Exam Preparation Guide. So as we said previously in the very beginning, that the exam for the LEED Green Associate and LEED AP specialities are still under LEED version 4. No announcement has been made, and no announcement will be made soon on the update of the exam, but please keep updated on either the website for USGBC or the social handles for USGBC. Any updates on the exam will be shown there. In addition to that, you can also access many sources through the education website under usgbc.org. There are, we're exceeding 900 and plus hours of education content. So you're more than welcome to access this platform, and also access the website for more information on the certification on different points updated for the LEED V4 and 4.1 for buildings. You can find many articles there for your information and increase your capacity directories there, courses are there, resources are there for you to provide you with more information that you need. So with that, we conclude today's session. So thank you very much for your attention. Tomorrow will be a deep dive into these categories in detail. We're going to talk about the different credits under each category and how to achieve them in LEED, and what are the ways you need to think of when you take the exam, and some tricks and some pointers for you who wants to take the exam further on. So thank you very much for listening. After this session, you will be receiving an email. The email will have very simple questions for you to answer as a survey. Once you answer those questions, you will receive your attendance certificate post completing the survey. So thank you very much. And now I'll see if you have any questions.
Hi, there's a question on for IQ, why occupant behavior and adaptive actions have not been included in the content. So I'll take that question. While we deep dive into this tomorrow, into the IEQ credit categories, occupant behavior and all of the actions are extensively upgraded in our LEED version 4.1 O&M rating system, where there's a category on occupant comfort and satisfaction. So while it's not just a survey, we also monitor carbon dioxide concentrations and TVOC content across the building, and also evaluate all regular building occupants for their comfort. So we'll go into that a little more in detail when we focus on the 4.1 O&M session.
So for those of you who want our emails, you can surely email us, my email and Deepti's email. So if you have any further detailed question you want us to help you on your buildings, or even questions on your exam prep, please email us. These are our emails. Any other questions?
There was one question on water metering in Saudi for residential buildings. So maybe we can elaborate on that tomorrow. Yes. And also a little more about the Living Standard campaign. I think we can do it tomorrow.
Yes. Okay. So thank you all for attending, and please make sure you answer the survey, give us your feedback, and that will also help you get the attendance certificate. So if we don't have any other questions, we can conclude the session, and hope to see you tomorrow.
Thank you. Good night. Bye.
Bye to all.